So when we're going to go to the ICMP inspection via MPF, we want the ASA to statefully inspect ICMP, which means actually pinging. We have two options. Using the ASA defaults, the ASA MPF default configuration, it means that we're going to just enable ICMP inspection in the default policy map, because the default policy map has the default class map attached, which the default class map matches on ICMP. So we just want to enable inspection for the ICMP, which means because the default policy map is globally applied, then this configuration is going to affect all ICMP traffic flowing back and forth to the ASA. If we don't want to make use of the default MPF configuration of the ASA, then we're going to match on ICMP traffic using an access list. Then we're going to configure a layer 4 class map and bind the ACL, and then configure a layer 4 policy map and bind the class map. And in the class map, we perform the inspection of ICMP, and then we apply the policy map globally or at the interface level. So if you want to visualize that, like in here, we configure the access list to match on ICMP, the ACL to match on ICMP. Then we call or bind the access list in a class map, in a layer 4 class map. Then we call or bind the class map in a policy map, layer 4 policy map. In the policy map. And in the policy map, we inspect ICMP because that's what we want to do. So that's where we define the firewall action. So the ACL and the class map are just used to match on the traffic. And then we call the class map and the policy map and we configure an inspection. And then the last step is going to be to apply the policy map. So to apply the policy map, or enforce the firewall to take action on my configuration. And we can do that either globally or per interface. So you have to visualize all of this process, because if something doesn't work, you have to understand where things can be broken by looking at the process step by step in there. Now verification steps is going to be, we can verify configure class maps with show run class map, configure policy maps with show run policy map, and verify applied policy maps with show run service policy. So which policy maps have been applied and how, globally or per interface. And of course, once we send traffic which is inspected by MPF, we say show service policy to see traffic statistics in there. Now let's go on the configuration side. So before we do any kind of MPF configuration, let's look at the defaults. So let's say show run class map. So we have this default class map name inspection default, which says I'm matching on default inspection traffic. Which what this means is, this is a macro in the ASA. If you say match question mark, default inspection traffic means that the ASA matches on pretty much all of those protocols. So this class map matches on all of those protocols in there, and as you can see, it matches on ICMP. So it matches on ICMP, it recognizes the ICMP traffic flowing to the ASA. Then that class map is being attached to the default policy map, which is named global policy. So I'm saying I'm going to give it a policy map, which means a firewall policy, and for the traffic match in that class map, I'm going to perform some kind of inspections. But as you can see, ICMP is not inspected by default, but the ASA does some default layer 7 inspections. For example, FTP, because we know that FTP, depending on, of course, how FTP server runs, in which mode, passive or active, FTP is a session which has two. It's a let's say an IP flow which has two sessions. It's going to have a control plane session, where the client connects to the server to authenticate and read the directory, the FTP directory, and then the data session, which means the FTP client actually gets to transfer anything from the FTP server to in there. So depending on how of course how the FTP server is configured, let's say if it's configured in active mode. So let's say router 4 is going to be an FTP server, and server A is going to be an FTP client. With our current configuration, when the client connects to the server, that's going to be the control plane session, which is going to be over TCP port 21. That session is going to work because traffic flows from 100 to 0, so high to low, and there's no access list to drop that traffic back and forth. So the control plane session works, but when actually I get to transfer files from the server, if the server runs in active mode, it means the server is going to initiate the data plane session or the transport session, or the transfer session, the data plane session or the transfer session. So data plane session is going to be running in active mode on TCP port 20. And of course, this session is going to be dropped by the ASA because this is not a reply of the control plane session. It's a different session on a different port number. And when I initiate that data plane, the transfer session, traffic flows now 0 to 100, high to low, low to high, which means if it's not allowed by an access list, it's going to be dropped. But fortunately, because the ASA inspects FTP by default, it means that when the control plane session is initiated to begin with between those servers, the ASA sees that the FTP session is negotiated to run in active mode, and which means the ASA expects this. So when the ASA sees this first session, the control plane session, is going to see that the client and the server negotiate to run in active mode, which means the ASA expects the server to initiate the second session for the transfer. And because it inspects FTP and understands the FTP language, it's going to look at the FTP header in the control plane session. It is going to allow the data plane traffic to work as well, even though it's going to flow low to high and is not allowed by an access list, just because the ASA inspects FTP by default. And in the end, show run service policy. The default policy map is globally applied, which means that affects all traffic flowing through the ASA back and forward. Let's also look in the ASDM4.SA refresh now. Likewise, and I forgot to specify this, also in the GUI, try to make sense of where you find things. And they do make sense. Like, it makes sense that if you want to configure like MPF, it should be under the configuration tab. And then in a configuration tab, you have a couple of options in there. And clearly this cannot be under the device setup because MPF is not a device setup functionality. It's not on device management. It's not on a site-to-site VPN. It's not on a remote access VPN, so it has to be under the firewall section. So try as much as you can to make a logic of where you can find things, because otherwise, if you don't make a logic out of it and you don't use something for a long while, you're gonna forget where you're gonna try to remember where to find it. But if it's gonna be very difficult to remember. But if you make a logic out of where you find things, you don't have to remember because you follow up on the same logic in there. Okay, so we go under firewall and then we go under service policy. In general, whatever it's not under the specifics configurations in there, if it's not, you're gonna find it under the advanced part of the ASDM. So if you look at the service policy rules, we have that default policy map, and if you say edit, you see it says it matches on the default inspection traffic, which means all of those protocols, which those are actually which protocols or which traffic the MPF default policy matches is going to be under default inspections. So if you go under default inspections, you're going to see the same thing we saw in show run class map, that default class map matches on all of those protocols. And as you can see, it also matches on For example, it matches on ICMP, and also it matches on, let's say, DNS. Now again, if you wonder like why would the ASA, if it by default inspects TCP and UDP and I cannot disable that, then why would I care? Why do I want to match on inspect DNS, or why would I want to inspect FTP, or why do I want to inspect SMTP? As I said before, in some cases, in the case of FTP, you want to inspect FTP because otherwise, because the traffic is asymmetric, like the control plane session is initiated by the client and the data plane session in active mode by the server, and that's going to be dropped if the ESA does not understand FTP, which means to inspect it. Or in other cases like DNS or SMTP, or HTTP inspections, you may want to do some deep packet inspections and look in the layer 7 header, not to allow traffic back and forth, but to configure some restrictions of that kind of traffic, of that type of traffic. So we see that the default class map matches by default on DNS and ICMP. But then we have to look on the ASA MPF functionality and look at the rules actions to understand, okay, I'm matching on that traffic, but what are the firewall rules I'm going to perform? So this is like going to be the policy map configuration in here, rule actions. And as you can see, I'm under the protocol inspection tab, and I'm seeing in here that DNS is inspected by default, also using a layer 7 policy map. So I'm doing actually some DPI inspections in DNS. But for example, ICMP is not inspected by default. So that's why ICMP like ping is not going to work. Even though the default class map matches on ICMP, by default the ASA doesn't inspect ICMP. So that's why, as you're going to see, ICMP ping is not going to work through the ASA unless we enable MPF to inspect also ICMP traffic statefully. Now, if we look at the CLI again, before we change this around. So if we say show run policy map, we see in here that I'm inspecting DNS using a layer 7 policy map. If you say show run policy map, that policy map is going to show you that for DNS inspection, I choose to say that the maximum message length has to be 512 bytes, and the message length from the client side is going to be auto negotiated. So if DNS traffic flowing through the ASA doesn't match those rules, the ASA is going to drop DNS traffic. If we say show run all policy map, show run all is going to also show the defaults. There you see, there you go, it's a lot more than that. So it's not only what it says, what is in show run, it's whatever we see in show run, all in there. Okay, now let's confirm that to begin with. If I'm going to ping this way, echo is going to work, but because the ASA doesn't inspect ICMP statefully, then the echo reply is going to be blocked by the ASA. Let's go on the ASA tree and say clear logging on the CLI. And let's go on router 1 and ping router 4. Ping 10.444, the loopback of router 4. Repeat 2 is going to be good enough. If we go, so as you can see, it doesn't work, but the echo request did work, but the ASA has blocked the echo reply. So as it says in here, deny ICMP source. I got an ICMP packet inbound on my internet interface with a source of router 4, and I had to route, if I would have allowed this packet, this would have been routed out on the inside interface, this into router 1. But it's being denied because ICMP is not safely inspected, and because traffic flows, so the ASA doesn't see the traffic in the state table to begin with because ICMP is not inspected. Then it's going to look, okay, traffic flows low to high, 0 to 100. The next thing it's going to do is going to say, do I have any inbound ACLs configured on this internet interface which allows this traffic? Which we have an inbound ACL applied, but doesn't allow ICMP echo replies, which means traffic is going to be dropped in the end. So type 0, code 0 means the echo reply was denied by the ACL. So when the ASA receives a traffic inbound on an interface, it's going to first look, do I have an entry in the file state table for that traffic? Meaning, has that session being already created and I just have to allow it back and forth? If it's not in the state table, then it's going to say, second, what are the security levels? First then it's going to look, do I have any inbound ACL configured on the interface where the traffic is being received? And if yes, does that ACL allow traffic? Then I'm going to allow it. If no, if the inbound ACL is not applied, so if yes, then take the ACL actions, allow or drop the traffic. If there is no inbound ACL, applied on that interface, then step number 3 is going to be, what are the security levels of the ingress and egress interfaces? So based on security levels, which is going to be 100 to 0, is the traffic allowed, and 100 to 0 is going to be allowed. Because in my case, this is the echo request. And step number 1, because it's the first packet from that session, there's no entry in the state table. There is no inbound ACL on that 100 level interface, which means I'm going to allow the echo request just because traffic flows high to low, which means it's allowed by default. But then in the other direction, it is going to be dropped, because when the echo reply comes from router 4 echo reply, the SA says, do I have that entry in the state table? Have I seen the echo request and have I kept that in the state table? No, because I'm not inspecting ICMP statefully. Then it's going to say, do I have an inbound ACL applied on that interface? Inbound on this interface, and I do have an inbound ACL applied in there. We have applied this from the previous example of the ACLs. I have, yes. But that inbound ACL doesn't allow that traffic, which means I'm gonna match on the implicit deny IP and any of the ACL. So it's gonna be a drop action, and that's what I see in the logs. So as you can see in the logs, it says that the echo reply traffic was dropped by the configured ACL, which was applied inbound on the internet interface. So now, if you want to make use of the default service policy, we just say edit, and we go under rule actions, and we also enable ICMP inspection in here. So we want the ASA to statefully inspect ICMP now, and we say OK, and apply, and send. And if you look back at the configuration now, we should see that under the policy map, inspect ICMP has been added by the ASA in there. So now when we ping again, the echo request is going to be allowed based on the security levels, because traffic flows high to low. But also, as the ASA forwards the echo request, is going to put an entry in the file state table. So when the echo reply is being seen by the ASA, is going to first look, as we know, in the state table, and the ASA says, oh, I've seen the echo request going out. This is the echo reply, and I have an entry in the state table. I'm going to now allow the traffic to flow, the echo reply to flow back in. So if you go now on router 1 and ping again, let's say no repeat, which is going to be 5 entries. This time it worked, successful. So if we go on ASA tree and say show service policy, inspect ICMP, it doesn't support inspect ICMP, just let's say show service policy. ICMP says 10 packets. So we've seen here that 10 packets, and we had no drops. It is 10 packets because that means 5 echo requests and 5 echo replies. And of course, if we would have looked in the show connection detail table, we should see ICMP traffic in the connection table. Let's ping again from router 1 and say repeat a high count. If you look at the connection table, then there we go, we see ICMP traffic from router 4, from router 1 to router 4 being in a state table. Because now I'm inspecting ICMP. Let's go on router 1 and kill this. But now if you go on ASA tree and say show run policy map, and we disable ICMP inspection, the connection table should of course be clear now because the session timed out. If we ping again now from router 1, it's not going to work clearly again. If you look in the ASA table in there, we still see that it has added, of course, the echo request in there, but because it's not statefully inspected, the echo reply is being dropped. Okay. Of course, another option would be going at the ASDM again. Let's say refresh now. We could achieve the same thing. I'm going to say, let's say add service policy rule. I'm going to apply it on which interface? I'm going to apply, let's say, on the inside. I want to do a per interface configuration. I'm going to name it inside MPF or inside policy. I'm going to say next. So that's the name of the policy map. So I'm configuring in here on which interface do you want to apply the service policy and what is the name of the policy map. I'm going to say next then. Now I want to match on my traffic, which is going to be which is going to be ICMP. So I don't want to match on an existing traffic class because I have no class maps configured, and I don't want to match on all traffic. And looking in here at the matching options, the only way I can match on ICMP is by using a access list. So I'm going to say the name of the class map is going to be inside CMap, let's say, give it a name of the class map, and I want to match on the traffic using an access list, and I'm going to say next. Then it's going to prompt me for the ACL, so I want to match on what traffic? On ICMP traffic, all of it. So I'm going to say source all ICMP traffic, any. Of course, we can, any means both IPv4 and IPv6. We can say only IPv4 or IPv6. I'm going to say any in my case, okay. Destination, likewise, any. And then I'm going to say service is not going to be IP, but ICMP. So I'm matching on all ICMP traffic. I'm matching on ICMP, add a service, okay. And then say next. And of course I have to finally enable ICMP inspection in here. And let's say finish. Say apply. So as you can see in the configuration, it first added the ACL. Then it added the class map matching the access list in here. So it's container by container. Then it created the policy map, called in the class map, said inspect ICMP, and then applied the policy map at the inside interface level. But I think I've done a typo in there because the ACL looks to be permit ICMP any 6 to any. I don't want ICMP version 6. Let's say cancel, and let's say edit again the rule. Say edit, and let's look at the ACL, and not any 6 but any in there, and let's say source any, okay, and then say okay again and say apply. and now it's good. So that functionality which I showed you from tools preferences, where you decide to you tell the ASA to show you what command is going to push down at the CLI level. It's also useful to detect any kind of misconfigurations you may have done in the GUI, as it was this case in here. Cancel. So now looking at the config, before we ping, let's look at the configuration side. So show run access list, not on router 1 but on ASA3. So this is my ACL, which matches on ICMP traffic. Show run class map. And now then my class map matches on that access list. And then show run policy map. And the policy map calls in the class map, and I'm inspecting ICMP. And then show run service policy. I'm attaching that policy map on the inside interface. So now again, ICMP should work because now I applied an MPF policy on the inside interface. I'm inspecting ICMP, which means likewise when echo goes out, ASA is going to safely inspect that and allow the echo reply back in. So going now on router 1 and pinging again, it should again work. Let's say without repeat. And there we go. If you go to ASA3 and say show service policy, interface, we should be able to say interface inside, because now my ICMP inspection is being done on a policy map which is applied on the inside interface. There we go. We see again I'm inspecting ICMP and 10 packets, which means 5 echo requests and 5 echo replies.